Good morning, students. So today we will discuss with the topic that is power in AC circuit. So either the AC circuit is connected with the resistance, inductance, or capacitance. So anything you may connect. So from this here we can get the power for the total circuit, and we will discuss few cases on this power in AC circuit. So now individually starting with the power in capacitor when connected to the AC source, power in inductor when connected to AC source, and power in resistance which is connected to the AC source, right? So here we are discussing overall the power in AC circuit, right? So AC circuit which we connected, so that's voltage, input voltage or applied voltage, that is V is equals to Vm sin omega t, where Vm is the peak voltage and V is the instantaneous voltage and omega is the frequency, right? So next, the current which is flowing in the circuit, I is equals to Im sin of omega t plus pi, where pi is the phase difference between the voltage and the current. Either it may be plus 90 degree or it may be minus 90 degree, or it vary between the 90 plus 90 and minus 90 or 0 30, anything it may. The pi is the phase angle between the voltage and to that of the current. Im is the peak current, and also we derive the relation Im is equals to Vm divided by Z, where Z is the impedance, and also we know the relation for the impedance in series LCR circuit, that is Z is equals to R square plus Xc minus XL whole square. If the circuit is only resistance, then this term is eliminated, so Z is equals to R, right? So if the circuit is only the capacitor, so there will be no R and XL, right? So that is Z is equals to Xc. So if the circuit is only the inductor, then Z is equals to XL. So if all the three are connected in the circuit, then Z is equals to under square root of R square plus Xc minus XL whole square. So this gives what the impedance, nothing but the resistance in series LCR circuit, right? So next, instantaneous power. That means power at any instant of time, we call that one as the instantaneous power, right? So that we know the relation P is equals to I into V, or V into I, or I square by R. So right, so here P is equals to I into V, where I is the instantaneous current and V is the instantaneous voltage. We have the relation here, right? So that is P is equals to I m sin of omega t plus pi, right, into Vm sin omega t, right? So we can write this one as instantaneous power P is equals to Im Vm sin omega t into sin of omega t plus pi. So this is in the form of sin A, sin B, where A is omega t and B is omega t plus pi, right? So this is in the form of sin omega t, sin of omega t, B is in the form of sin A, sin B. So from the trigonometry we know the formula for sin A, sin B, right? So substitute that formula. P is equals to Im Vm. So sin A, sin B is 1 by 2, right? So 1 by 2 cos of A minus B, that is omega t minus of omega t plus pi, right? So sin A sin B formula, we have half cos of A minus B minus cos of A plus B, omega t plus pi, right? So simplify this one, 1 by 2 we can take common, that is Im Vm cos of omega t minus pi. So minus cos of 2 omega t plus pi, right? So here plus omega t minus omega t get cancelled. So we can write cos of minus pi, that is minus pi, that is cos of minus theta is cos theta itself, right? So instantaneous power P is equals to Im Vm divided by 2, right? So this we can write cos pi minus cos of 2 omega t plus pi. So this is what, this is the instantaneous power. So at any instant of time, if we want to calculate the power, so we have the relation P is equals to Im Vm by 2 into cos pi minus cos of 2 omega t plus pi, right? So next one is the average power. So average power is denoted by P bar, that is equals to I V. So within the angled brackets, we can write that, that is if we write in the angled bracket, so that is what the average power, right? So here IV we have the value, that is Im Vm constant, so we can take outside within the angled brackets. So cos pi minus cos of 2 omega t plus pi, right? So here cos pi is independent of a time function, right? So we can find the average only which relates to the time function, that is f of t, that is equals to 1 by t 0 to t f of t dt. So this is the relation to find the average of any quantity which relates with the time. So here cos pi is independent of the time relation, and here cos of 2 omega t. Here we have the time relation. So if we find the average for this value, so this is constant. Again, this is constant. We can take outside Im Vm by 2 cos pi minus average of cos of 2 omega t plus pi. So in the previous, we find the value here cos of 2 omega t. So the average value of cos of 2 omega t is 0. So here also the value of the average value of cos of 2 omega t is 0. So we can substitute this one as 0. So we get Im Vm by 2 cos pi. So this gives what the average power, where pi is the phase difference between the current and to the voltage, right? So for the instantaneous power, we have an extra term cos of 2 omega t plus pi. So in average power, this quantity becomes 0. Average of cos of any value which relates with the time, so that value is 0, right? So we get P is equals to Im Vm by 2 into cos pi, right? So by using this relation, we will discuss few cases, right? So that is, first case, if the circuit is purely resistive, right? So if the circuit is purely resistive, so that means only the resistor is connected to the AC source, right? So in AC source, the current and voltage both are in phase. That means the angle between current and voltage is 0. That means phase difference between the current and voltage is 0, right? So here by using this relation, or this one is equation 1, right? So when pi is equals to 0, cos pi, that is equals to 1. Cos of 0 is 1, right? So there is a maximum power dissipation in purely resistive, right? So substitute this into the above equation 1, we get P is equals to Im Vm divided by 2. So idunna ನಾವು individual resistor allidaga we find the power, so we get the same relation P is equals to Im Vm by 2. So this is the maximum power dissipation, or maximum power dissipated in the circuit, right? So this is when the resistor is connected to the AC source. So this one is the first case. So when resistor is connected to the AC source, so current and voltage both are in phase. So we write the diagram, phasor diagram. V and I both are in a parallel. So I and V are parallel together. That means the angle between I and V is 0. So as this value is 0, so cos pi is 1, right? So as cos pi is 1, substituting here I am Vm by 2. So here there is a maximum power dissipation or power loss in the resistive circuit, right? So next. So next in the case 2. So either purely inductive circuit, so purely inductive circuit or purely capacitive circuit, right? So ಇಲ್ಲಿ first purely resistive circuit. So here either it may be purely inductive or purely capacitive. So in these two cases also the phase difference or phase angle between the voltage and to the current is always equals to 90 degree. So ಒಂದರಲ್ಲಿ plus 90 degree ಇದ್ರೆ ಇನ್ನೊಂದರಲ್ಲಿ minus 90 degree ಇರುತ್ತೆ, but angle ಏನಿರುತ್ತೆ ನಮಗೆ 90 degree ಇರುತ್ತೆ, right? So that means cos pi or cos pi by 2. So value of cos pi by 2, so that is equals to 0, right? So that is average power P is equals to 0. That means no power is dissipated in the circuit. Even though current is flowing in the circuit, so there is no power loss. So that type of current we also call that one as wattless current. Right? So wattless current is the current even though the power dissipation is 0. When power dissipation is 0, there is a current which is flowing in the circuit, either in inductive circuit or it is in purely capacitive circuit. So in that capacitive circuit or inductive circuit, so the current is flowing, so that current we call as the wattless current. This current flowing in the circuit even when power dissipation is 0. So ನಮಗೆ power 0 ಇದ್ದಾಗಲೂ ಕೂಡ ನಮಗೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆ. ಸೊ ಅಂತ ಕರೆಂಟ್ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ವಾಟ್ಲೆಸ್ ಕರೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. This circuit ಅಲ್ಲಿ we have some resistance, so we have some inductance, that is inductive reactance and also capacitive reactance. So some values ಅಂತೂ ಇದ್ದೇ ಇರುತ್ತೆ. So this value is not equals to 0, right? So pi is not equals to 0. That means cos pi is not equals to 0. That means cos pi has some value or the value. That means here cos pi we are getting some value. So that means we are getting the power. That means there is some power dissipation or power dissipation in the circuit. So either this power dissipation in the circuit alli namage purti series LCR ಆಗಿರಲೇಬೇಕು ಅಂತ ಏನಿಲ್ಲ. Either it may the circuit is in resistance with the inductor or resistance with the capacitor or it may be series LCR circuit. So you ಮೂರರಲ್ಲಿ ಯಾವುದಾದರೂ ಕನೆಕ್ಟ್ ಆಗಿದ್ರು ಕೂಡ we get some power dissipation in the circuit, because so if we have only the capacitor and resistance, so XL irodilla, so XC has some values and R has also some values. So if we do simplify madidre tan inverse of some angle we are, so that if we substitute in cos pi again we getting some value. So namage one value barta ide andre there is a power dissipation in the circuit, either it may be RL or C or series LCR circuit, right? So this is the third case, right? And the last is fourth case. At resonance. So now resonance na ella observe ಮಾಡ್ತೀವಿ. Resonance we are observing only in the series LCR circuit. So ಇಲ್ಲಿ ನಮಗೆ ಈ ಮೂರು ಟರ್ಮ್ಸ್ ಇದ್ದಾಗ ಮಾತ್ರ we are observing the resonance. That means at resonance we have the condition Xc is equal to XL. Right? So that means Xc is equal to XL means this numerator value is 0. 0 by anything is 0. So tan inverse of 0 is 0, right? So tan 0 0 irutte, tan inverse of 0 kuda irutte 0. That means pi value ಏನು ಬರ್ತದೆ ನಮಗೆ 0, right? So when pi value is 0, so cos pi is equals to 1, right? So 1 into this value we getting again p is equals to Im Vm by 2. So again in this case also maximum power dissipation in the circuit. So in ಎರಡು case 1 and in case 4 we getting the maximum power dissipation only when power dissipation is 0 in the case of purely inductive or in case of purely capacitive, right? So there is some value we getting the power dissipation in series LCR circuit. So maximum irodilla, minimum irodilla, so we getting some power dissipation. Right, so that is when in the series LCR circuit. If the same series LCR circuit is at resonance, so again we getting the maximum power dissipation P is equals to Im Vm by 2. So you have to important. So yaವಾಗ ನಮಗೆ maximum dissipation ಇರುತ್ತೆ when the series LCR circuit is at resonance and also when the AC source is connected to the pure resistor. Only resistor connect ಮಾಡೋದು ಕೂಡ ನಮಗೆ power dissipation, right? So this is about the power in AC circuit. So by this relation we discuss all the four cases. So this is the main important. So now individual ಆಗಿ ಕೂಡ ಇದನ್ನ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ, but using this relation again we discuss, right? So this also we can write power is equals to Im by root 2 into Vm by root 2 into cos pi, right? So we can write this one as P is equals to Im by root 2 Vm by root 2 into cos pi. We know the value of Im by root 2 and Vm by root 2. So those values we call as R values, right? So power is equals to IRMS into VRMS into cos pi, right? So or we can write this one as I into V cos pi, where cos pi is called as power factor. So problem solve ಮಾಡಬೇಕಾದ್ರೆ ಇದು ತುಂಬಾ important. So we call cos pi as power factor, that is power factor is equals to cos pi. So ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ find the power factor. So power factor ಅಂದ್ರೆ ಟೋಟಲ್ cos pi ನ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಿದ್ವಿ. So cos pi ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ರೆ ನಾವು ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ, ಪವರ್ ಫ್ಯಾಕ್ಟರ್. ಓನ್ಲಿ pi ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಫೇಸ್ ಡಿಫರೆನ್ಸ್, ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ cos ಅಲ್ಲಿ ಫೈಂಡ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ ನಾವು, ಪವರ್ ಫ್ಯಾಕ್ಟರ್, ರೈಟ್? ಸೊ ಇದು ಒಂದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ರಿಲೇಷನ್. So power factor is denoted by cos pi, right? So this is very very important. So ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆದ್ರೂ ಕೂಡ ನಮಗೆ ರಾಂಗ್ ಆಗುತ್ತೆ, right? So we take this one as power factor. So again P is equals to V into I. So as we discussed in DC current, right? So current electricity ಅಲ್ಲಿ ನಾವು ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ, power loss is equals to I into V, right? So this is about the power in AC circuit, right? So the next topic is LC oscillator. So now first year ಕೂಡ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ oscillator. So mechanics ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿರೋದ್ರಿಂದ spring ಕೂಡ oscillate ಆಗುತ್ತೆ. That is, if any object is connected to the spring, it gives the oscillation. So that one we call as mechanical oscillator. ಅಥವಾ simple pendulum experiment ಕೂಡ ಮಾಡಿದ್ವಿ. When a bob is connected to a string, so that is also oscillates, right? So those two are the example for the mechanical oscillator. So here LC oscillator is the electrical oscillator. So this is also behaves as a simple harmonic motion. So this executes the simple harmonic motion, and it is similar to that of the mechanical oscillator that we observed in a spring, and also that is the spring balance, and also in simple pendulum, right? So we know capacitor stores electrical energy. So previous chapter ಅಲ್ಲಿ ನಾವು ಸ್ಟಡಿ ಮಾಡಿದೀವಿ capacitor stores the electrical energy, and U is equals to 1 by 2 Q square divided by C, right? So this is the energy stored in the capacitor. So ಇದನ್ನ ನಾವು last class ಅಲ್ಲಿ, that is last chapter ಅಲ್ಲಿ derive ಕೂಡ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. So this is the energy which is stored in the capacitor. So similarly inductor also stores magnetic energy or magnetic field, right? So it stores the magnetic energy. So capacitor stores the electrical energy. So capacitor is denoted by the C, capacitance of a capacitor, and L is the inductor, that is inductance of an inductor. So inductor ಕೂಡ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ ಯಾವುದನ್ನ ಎನರ್ಜಿನ. So capacitor ಕೂಡ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ ಯಾವುದನ್ನ ಎನರ್ಜಿನ. So here we are going to discuss about what is LC oscillator, right? So it is important. It stores the energy. Capacitor also stores the energy, and inductor also stores the energy. So capacitor alli electrical energy store andre, inductor alli magnetic energy. That means magnetic field ಏನಾಗುತ್ತೆ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. So ನಾವು ಆ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದಾಗ in detail ಆಗಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, right? So electric oscillator, when and charged when a charged capacitor is connected to an inductor of inductance L, right? So one charged capacitor na ಏನು ಮಾಡ್ತಿದೀವಿ, inductor ಗೆ connect ಮಾಡ್ತಿದೀವಿ, right? Charge in the capacitor and current in the circuit exhibits the phenomenon called electrical oscillations. Exhibits the phenomenon, so that is called as electrical oscillation. So anta division namu bartidivi LC oscillator. So it exhibits the phenomenon, so that phenomenon is the electrical oscillation, right? So this electrical oscillation is that of the electrical oscillation which are produced in the LC oscillator. Electrical oscillation is similar to the mechanical oscillations. So electrical oscillations yaudike similar irutte mechanical oscillations. That means we observe the oscillations in simple pendulum. So simple pendulum alli ನಾವು ಏನು oscillations na observe ಮಾಡ್ತೀವಿ, so same oscillations we are observing in the electrical oscillations. So that is the electrical oscillator, right? So this is when a charged capacitor is connected to the inductor. So one charged capacitor na inductor ge connect ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, charge in the capacitor and current in the circuit. So so we get in the electrical oscillation. So electrical oscillations means energy is transferring from capacitor to inductor and again from inductor to capacitor. So ಈ ತರ oscillate ಆಗೋದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, electrical oscillations. That is charges are oscillating from capacitor. First ಏನಾಗುತ್ತೆ ನಮಗೆ charges which are oscillating. So charges, that is Q, which is oscillating from capacitor to inductor and again from inductor to capacitor. So certain time ಆಗ್ತಿದಂಗೆ charges which are present in the capacitor is shifted to the inductor. After certain time the charges, so ಇಲ್ಲಿ capacitor ಅಲ್ಲಿ complete ಆಗಿ charge ಏನಾಗುತ್ತೆ, empty ಆಗುತ್ತೆ. So that is transferred to the inductor. So again ಇಲ್ಲಿ complete ಆಗಿ ಖಾಲಿ ಆದ್ಮೇಲೆ inductor ಅಲ್ಲಿರೋ charge ಏನಾಗುತ್ತೆ ಮತ್ತೆ capacitor ಗೆ move ಆಗುತ್ತೆ. ಇಲ್ಲಿವರೆಗೂ inductor ಅಲ್ಲಿ charges ಖಾಲಿ ಆಗೋವರೆಗೂ, right? So that means here we are going to discuss about the energy oscillations between the capacitor and to the inductor, right? So energy capacitor ಅಲ್ಲಿ store ಆಗಿರುತ್ತೆ. So when it is connected to the inductor, ಇದರಲ್ಲಿರೋ energy ಎಲ್ಲದನ್ನು inductor ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡುತ್ತೆ. So when its energy becomes zero, so again energy is leaving from the inductor. So ಇಲ್ಲಿಂದ ಏನಾಗುತ್ತೆ ಮತ್ತೆ magnetic energy release ಆಗುತ್ತೆ. So release ಆಗಿರೋದು in terms of current ಅಲ್ಲಿ ಮತ್ತೆ capacitor ನ ಏನು ಮಾಡುತ್ತೆ, charge ಮಾಡುತ್ತೆ. Charging and discharging in the capacitor. So same as here in the inductor. So ಎರಡರಲ್ಲೂ ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, energy oscillate ಆಗುತ್ತೆ. So first ಇದರಲ್ಲಿ ಜಾಸ್ತಿ ಇತ್ತು ಅಂದ್ರೆ ಇದರಲ್ಲಿ zero ಇರುತ್ತೆ. So ಇದರಲ್ಲಿ zero ಆಗ್ತಿದ್ದಂಗೆ ಇದರಲ್ಲಿ maximum energy ಏನಾಗುತ್ತೆ, ಸ್ಟೋರ್ ಆಗುತ್ತೆ. So ಅದನ್ನ in detail ಆಗಿ ಸ್ಟಡಿ ಮಾಡೋಣ. Right? So initially consider a capacitor. So your capacitor is going to, initially the capacitor is charged. So the maximum value of the charges which are present in the capacitor, we take on that one as Qm, where Qm is the charges which are stored in the capacitor, right? So one plate of the capacitor, parallel plate capacitor, one plate is positively charged and the another plate is negatively charged. So ಎಲ್ಲಿವರೆಗೂ ಚಾರ್ಜ್ ಆಗಿದೆ, it stores the charges, that is Qm is the charges which are stored in the capacitor, right? So that capacitor we call as the charged capacitor, right? So this charged capacitor is connected to the inductor. So circuit initially ಏನಿರುತ್ತೆ, open ಇರುತ್ತೆ. So ಈ ತರ ಸ್ಪೇಸ್ ಬಿಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ that means it is an open circuit, right? So here we take on the terminals as A and B, where A and B is the inductor. It having the inductance L. So that is the intrinsic property of the inductor, right? So now when we connected this charged capacitor to the inductor, that means initially it has energy. So energy is stored in the capacitor. Charges are flowing through this circuit. That means number of charges flowing, that is dq with respect to time. So time change ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ ಇದರಲ್ಲಿರೋ ಚಾರ್ಜಸ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So that is dq by dt. We call that one as the current, right? So q ಏನಾಗ್ತಾ ಹೋಗ್ತಾ ಇದೆ, ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. That means decreasing. That means we take on current I is equals to minus dq by dt. Why minus symbol? Because charges ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So ಎಲ್ಲಿವರೆಗೂ decrease ಆಗುತ್ತೆ, until when it reaches to zero, right? So now at a particular time, so at any instant of time, considering at any instant of time t, so ಯಾವುದೋ ಒಂದು particular time ಅಲ್ಲಿ, so number of charges which are present in the capacitor ಏನಿರುತ್ತೆ ನಮಗೆ, where q is the charges which are present in this capacitor. So maximum Qm is there. So certain time, after some 5 seconds, after some 10 seconds, the charges are decreasing. So where that is the Q is the charge which is present in the capacitor and I is the current flowing in the circuit. right? So as the current flows through the inductor, so ಇಲ್ಲಿ charges ಕಮ್ಮಿ ಆಗ್ತಾ ಇದೆ, right? So after certain time t ಅಂದುಕೊಂಡ್ರೆ we will remove some charges on the capacitor. So charges ಏನು ಮಾಡಿದೀವಿ, decrease ಮಾಡಿದೀವಿ. So here there exists an voltage, right? So ಇಲ್ಲಿ ಕೂಡ charges ಇದೆ ಅಂದ್ರೆ voltage ಇದೆ, ಇಲ್ಲಿ current flow ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಕೂಡ ನಮಗೆ voltage ಇದೆ, right? So applying Kirchhoff rule to this circuit. So ಇಲ್ಲಿ ನಾವು Kirchhoff's rule ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, again this is a capacitor having some capacitance C, then we define that one as Q divided by V. So voltage across this capacitor V is equals to Q divided by C at any particular instant of time, right? So voltage across this capacitor we can take that one as Q by C, or we can write voltage across the capacitor, right? So here it is positive terminal and here it is negative terminal. So now either a loop consider ಮಾಡಿದ್ರೆ, so ಇಲ್ಲಿ positive ಇರುತ್ತೆ, opposite negative ಇರುತ್ತೆ, that means minus V L that is equals to 0. So there is no resistance in this circuit, right? So external resistance ಇಲ್ಲ, so IR product ಏನಿರುತ್ತೆ ನಮಗೆ 0, right? So VC is the voltage across this capacitor, so that we can write Q divided by C minus VL is the voltage across the inductor, so that is L into di by dt, that is equals to 0, right? So di by dt into L, so that is rate of change of current with respect to time. So again from this relation here we taken I is equals to minus dq by dt. So substituting here, so we get Q divided by C minus L d by dt minus dq by dt, that is equals to 0, right? So if we take a minus outside, Q by C plus d square Q by dt square, that is equals to 0, right? So we rearrange, so ಇದನ್ನ ನಾವು rearrange ಮಾಡಿ ಬರ್ಕೊಂಡ್ರೆ d square Q by dt square plus Q by C, that is equals to 0, right? So we know for a resonance, so resonance ಅಲ್ಲಿ ಇದ್ದಾಗ omega naught square, that is equals to 1 divided by LC. So this is when at resonance XC is equals to XL, omega naught square is equals to 1 by LC, right? L into d square Q by dt square. Now divide this whole equation by L, or taken L to the RHS, we can write dq square by dt square plus Q divided by LC, that is equals to 0. So from the resonance 1 by LC we can write that one as omega naught square, right? So this equation d square Q by dt square plus omega naught square Q, that is equals to 0, right? So this is the equation which represents the simple harmonic motion. So now class 11th ಅಲ್ಲಿ ನೆನಪಿದ್ರೆ ಅಲ್ಲಿ ಕೂಡ ನಮಗೆ d square x by dt square plus omega naught square x, that is equals to 0, that is omega into omega square into x, that is equals to 0. So this equation represents what? The simple harmonic motion, right? So from this equation we can say that in an oscillator, that is in capacitor which is connected to the inductor, so here it exhibits the simple harmonic motion, that means charges are exhibited the simple harmonic motion. So iduna now theoretical statement alli ಹೇಳಿದ್ವಿ, that means it exhibits the electrical oscillation. So this gives what the mathematical proof for the relation, right? So ಈ equation ಏನು represent ಮಾಡ್ತಿದೆ ಅಂದ್ರೆ, this equation represents the simple harmonic motion, right? So idu namge proof for the LC oscillator. So namge exam alli enadru LC oscillator na 3 marks ikkididre, we need to write the definition, and with this diagram up to here we need to write the relation, right? So initially the charge is stored, that is Qm, stored maximum charges when t is equals to 0, and as the capacitor which is connected to the inductor, the charges are starts to flow in the circuit. So charges flow up to the ಅಂದ್ರೆ that means current is flowing, right? So current flow up to the ಅಂದ್ರೆ charges decrease ಆಗ್ತಿರೋದ್ರಿಂದ ನಾವು ಅದನ್ನ minus dq by dt ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ, right? So after some time, at any instant of time, so ಸ್ವಲ್ಪ ಟೈಮ್ ಆದ್ಮೇಲೆ where q is the charges which are present in the capacitor and I is the current which is flowing in the circuit. So now applying the Kirchhoff law, voltage across the capacitor that is equals to voltage across the inductor, or we can write Vc minus Vl is equals to 0. So these are from the formula for the voltage across the capacitor and inductor. So substituting the values and simplifying, we get the relation. So this relation is the second order differential equation, so which represents for the simple harmonic motion, right? So now if we find the solution, so in previous class kuda same relation banditu andu, so there we find the relation for q, right? So here also if we find the solution for this equation, so we get the solution q is equals to qm cos of omega naught t plus pi. So this is one solution for this equation, second order differential equation ge one solution is there. So that solution we take q is, so ilida idu yav tara bantu andre idana ನಾವು maths ಅಲ್ಲಿ study ಮಾಡ್ತೀವಿ. So there is no necessity to derive to get this relation. So now direct ಆಗಿ ಇಲ್ಲಿ ಬರ್ಕೊಂತಾ ಇದ್ದೀವಿ, right? So initially what I said means the charges q is equals to qm when t is equals to 0. So now substituting here to find the phase angle between the charges and to that of the current, right? So substituting here in place of q, qm that is equals to again qm cos of omega naught t. So t is 0, 0 into omega naught is 0 plus pi. So qm get cancelled. 1 is equals to cos pi. That means power factor is 1. So from this we can write pi is equals to 0. That means there is no phase difference between the current and to that of the charges, right? So substituting pi is equals to 0, we get q is equals to qm cos of omega naught t. So e pi value na illi substitute ಮಾಡ್ತಿದೀವಿ, ಇಲ್ಲಿ substitute ಮಾಡ್ತೀವಿ. Again from the relation we written I is equals to minus dq by dt. So minus d by dt, we know the value of q, that is qm cos of omega naught t. So differentiating this equation we get minus qm taken outside. So differentiation of cos minus sin theta minus sin omega naught t into omega, right? So from this I is equals to minus into minus plus qm omega naught sin of omega naught t. So qm omega naught we can write that one as I is equals to im sin omega naught t. So this is the current which is flowing in the circuit at any instant, right? So that is the I is equals to im sin omega naught t, right? So as the current is flowing, that means here the inductor starts to store the energy, right? So initially capacitor stores the energy, so we use C, that is the energy which is stored by the capacitor, that is equals to half, we know the formula q square divided by C, right? So the maximum charges which are stored here is 1 by 2 qm square by C, right? So in the initial case the energy which is stored in the capacitor is given by the relation 1 by 2 qm square by C. So at that time the energy which is stored in the inductor, that is U L, that is equals to 0, because in the starting case we taken this one as the open circuit. So only charged capacitor ತಗೊಂಡಿದ್ದೀವಿ, ಇಲ್ಲಿ ಯಾವುದೇ ತರಹದ energy store ಆಗಿಲ್ಲ. That means total energy that is equals to half qm square by C. right? So initially total energy is half qm square by c. After connecting this one, charger starts to flow and it comes to 0. So charges complete again agutte, empty agutte. So now the energy stored in the capacitor, so this is in the first case. So in the second case, so energy stored in the capacitor is equals to 0 because it shares complete its charges across the inductor. So illira ella charge kuda enagide discharge agide. So current flow agtide across the inductor andre enagutte illi energy 0 agutte. Energy stored in the capacitor enagutte 0 agutte. Then energy in the inductor. So illinda illige flow agtide andre current flow agtide along across the inductor. So then the energy is stored. So that is half L Im square, where Im is the maximum current which is flowing in the circuit. So we relate that one, Im. So Im is the one, so that is Im is equals to Qm omega naught, right? So ಕೆಳಗಡೆ ಬರ್ದಿದ್ದೀನಿ ಕಾಣುತ್ತೋ right, where Im is equals to Qm omega naught, where Qm is the maximum charge. So same wise ella charge flow agide andre current ಏನು ಇರುತ್ತೆ ನಮಗೆ maximum irutte. So that is the energy which is stored in the inductor, right? So Un is equals to half L Im square. So again here the total energy is equals to half L Im square, right? So next ಇದು complete charge ಆದಾಗ next again it flows the due to stored energy ಇಲ್ಲಿಂದ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ನಮಗೆ it starts to flow the current. So current ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ flow ಆಗಕ್ಕೆ start. As the current which is flowing across the capacitor, then capacitor gets charged. So positive, again here it is negative. But polarity in the capacitor ಏನಾಗುತ್ತೆ ನಮಗೆ opposite ಆಗುತ್ತೆ. Initially left side plate ಅಲ್ಲಿ positive ಇತ್ತು, after it loses its complete charges, again it gets charges, then right side ಏನಿರುತ್ತೆ ನಮಗೆ positive. Again this process continues. So ಅವಾಗ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ energy in the inductor ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ. Again here we get the energy in the capacitor. So this process keeps on going. So that means the energy is oscillating. Energy is oscillating between capacitor and inductor. So this we call as LC oscillator. So energy ಏನಾಗ್ತಿದೆ oscillator ಆಗ್ತಿದೆ. That means initially capacitor energy ಇರುತ್ತೆ, inductor ಅಲ್ಲಿ ಇರೋದಿಲ್ಲ. So next case ಅಲ್ಲಿ capacitor 0 ಆಗುತ್ತೆ energy, inductor ಅಲ್ಲಿ energy ಇರುತ್ತೆ. Again next case ಅಲ್ಲಿ inductor ಅಲ್ಲಿ 0 ಆಗುತ್ತೆ, capacitor ಅಲ್ಲಿ ಮತ್ತೆ energy ಬರುತ್ತೆ. That means energy is transferring from capacitor to inductor and from inductor to capacitor. That means energy ಏನಾಗ್ತಿದೆ oscillate ಆಗ್ತಾ ಇದೆ, right? So this is about the LC oscillator. But actually in ಇದು ನಮಗೆ ಐಡಿಯಲ್ ಕೇಸ್ ಇರುತ್ತೆ. ಬಟ್ ಆಕ್ಚುಲಿ ನಮಗೆ ರೆಗ್ಯುಲರ್ ಇನ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಥವಾ ಇನ್ ಡೈಲಿ ಲೈಫ್ ಅಲ್ಲಿ ಇದು ನಾಟ್ ಪಾಸಿಬಲ್ ಇರುತ್ತೆ. ಬಿಕಾಸ್ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಎಷ್ಟು ಎನರ್ಜಿ ಇರುತ್ತೋ ಅಷ್ಟು ಎನರ್ಜಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಲ್ಲ. ಬಿಕಾಸ್ ದಿಸ್ ಕೆಪಾಸಿಟರ್ ಹ್ಯಾಸ್ ಸಮ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ದಟ್ ವಿ ಕಾಲ್ ಆಸ್ ಇಂಡಕ್ಟಿವ್ capacitive reactance, and also inductor has also some resistance, that is inductive reactance. So it opposes some flow of current in the inductor and it opposes the flow of current in the capacitor. So ಎರಡರಲ್ಲೂ ಕೂಡ opposition ಇರೋದ್ರಿಂದ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 10 joule of energy capacitor ಅಲ್ಲಿ ಇದ್ರೆ ಐಡಿಯಲ್ ಕೇಸ್ ಅಲ್ಲಿ ಮಾತ್ರ 10 joules of energy inductor ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ. ಬಟ್ ಇನ್ ರಿಯಲ್ ಕೇಸಸ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ 10 joule ಇತ್ತು ಅಂದ್ರೆ some 8 joules to energy transfer ಆಗುತ್ತೆ ಯಾವುದಕ್ಕೆ ಇಂಡಕ್ಟರ್ ಗೆ. ಅಗೇನ್ ಫ್ರಮ್ ಇಂಡಕ್ಟರ್ ಟು ಕೆಪಾಸಿಟರ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಬೇಕು ಅಂದ್ರೆ some 6 joules ಅಷ್ಟು ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ there is an energy loss while oscillating in between the capacitor and inductor, and finally it comes to 0 ಅಂದ್ರೆ ಡೆಡ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ. ಅದನ್ನ ನಾವು ಮೆಕ್ಯಾನಿಕ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ. ಸೊ ದಟ್ ಟೈಪ್ ಆಸಿಲೇಷನ್ ನಾವೇನಂತ ಕರಿತೀವಿ, ಡ್ಯಾಂಪ್ಡ್ ಆಸಿಲೇಷನ್ ಅಂತಾನು ನಾವು ಕರ್ಕೊಂಡಿದೀವಿ, ರೈಟ್? ಸೊ ಗ್ರಾಫ್ ಬಂದ್ರೆ ಯಾವಾಗಿರುತ್ತೆ ನಮಗೆ keeps on going and finally it comes to 0. So there is no oscillation. So ಅದೇ ತರನೇ ಇಲ್ಲಿ ಕೂಡ 10 ಇತ್ತು ಅಂದ್ರೆ some loss 8 ಬರುತ್ತೆ 6 4 2 again 0. So ಅಲ್ಲಿಗೆ after some time the energy in the system gets completely to the zero. So this is one case, and in the second case, as the energy is transferring, so here some of the energy is radiating outside. So energy store ಆಗ್ತಿದೆ ಅಂದ್ರೆ it radiates the energy, so in the form of electromagnetic waves. ಆ ಚಾಪ್ಟರ್ ಬಂದಾಗ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. So these electromagnetic waves which are radiated from the inductor that we are used in radios and also in TV. So TVs ಅಲ್ಲಿ ಮತ್ತೆ ರೇಡಿಯೋಸ್ ಅಲ್ಲಿ ನಾವು ಏನು ಸಿಗ್ನಲ್ಸ್ ನ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ತೀವಿ, ಸೊ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂತೀವಿ, ರೈಟ್. ಸೊ ಅಗೇನ್ ಇಲ್ಲಿ ಎನರ್ಜಿ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಲಾಸ್ ಆಗುತ್ತೆ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ಸ್, ರೈಟ್. ಸೊ ಫ್ರಮ್ ದಟ್ ರೀಸನ್ ಆಲ್ಸೋ it will finally dead. So in circuit ಏನಾಗುತ್ತೆ, finally it comes to zero, that means it gets to dead, right. So this is about the LC oscillator. So if they ask for 3 marks, so up to here we need to write the explanation. So we need to prove that LC oscillator shows harmonic, that is simple harmonic motion na exhibit ಮಾಡ್ತಿದೆ ಅನ್ನೋದನ್ನ ಈ equation ಇಂದ ನಾವು represent ಮಾಡ್ತೀವಿ, right. So on the last topic remaining, that is transformer, that we discussed in our next class. Thank you.